Born 4 years apart, brothers Wilbur and Orville Wright grew up in a small town in Ohio. They shared an intellectual curiosity and an aptitude for science, at a time when the possibility of human flight was beginning to look like a reality. Together, the Wright brothers developed the first successful airplane in Kitty Hawk, North Carolina, and together they became national heroes. Considered the fathers of modern aviation, they developed innovative technology and inspired imaginations around the world. Their work in lift proved to be fundamental to aviation, and today we'll explain to you, well, what is lift?
Here we can see that air that travels over the wing speeds up and air that travels below the wing slows down, producing lift.
Lift, like most things in physics, can be explained in more simple terms using Newton's 3 laws of motion, the fundamental principles of all things moving. Newton's first law states that a body will remain at rest or in a constant velocity unless acted on by an external force. In terms of lift, this is demonstrated as the air particles remain at a constant velocity until they come into contact with the external force of the airfoil. Newton's second law states that the rate of change of the momentum of a body is directly proportional to the force applied and is in the direction of the force applied. In terms of lift, this is demonstrated as the airfoil cuts through the air and changes the direction and velocity of the air. Newton's third law states that every action has an equal and opposite reaction. As the airfoil cuts through the air and pushes the air downwards, causing downwash, the equal and opposite reaction is demonstrated as the air pushes the wing upwards, causing lift.
Bernoulli's principle states that if the total amount of energy in the air remains constant, any increase in kinetic energy will cause an equal decrease in potential energy. The easiest way to explain Bernoulli's principle and how it applies to an airfoil is using this Venturi model, which we made. As you can see, as the fluid enters the restriction, its flow rate must increase, so therefore its pressure will decrease, as I'm showing you now. This is exactly what happens over the top surface of an airfoil, and it is also what Bernoulli's principle told us. You can also see clearly that the restriction is the same shape of an airfoil of a wing, and this is how Bernoulli's principle applies to an airfoil. Therefore, it is evident that an airfoil changes the relationship between air pressure and velocity in the same way it is changed in a Venturi, and along with Newton's 3 laws of motion, this Venturi shows how lift occurs in an airfoil. This SolidWorks model verifies that if we add no energy to the fluid, as it enters restriction, its flow rate will have to increase and pressure will decrease, just as water speeds up to the shallow part of a stream and also as air speeds up over the top surface of an airfoil. Simultaneously, the impact of the air on the lower surface of the airfoil increases the pressure below. This combination of pressure decrease above and increase below produces lift.
The coefficient of lift is a dimensionless number which relies on 2 factors: the angle of attack of the wing and the shape of the wing.
The modern lift equation. L is equal to CL by rho by V squared divided by 2 multiplied by A. What do these letters mean? L stands for lift. Lift is measured in kilograms by meters per second squared, or newtons, N. CL is the lift coefficient. We'll touch back on the lift coefficient later. This is rho, not P. Rho is the air density, which is measured in kilograms per meters cubed. V squared is velocity, and this case stands for airspeed, which is measured in meters per second. A is area, in this case wing area, which is measured in meters squared. Putting all these factors together, we can find out how much lift a wing generates.
My name is Dr. Ronan Higgins. I'm the course director for aeronautical engineering at the University of Limerick, and I'm delighted to welcome the students here to our aeronautical engineering facilities to discuss their chosen topic of lift.